we don't have enough time to talk about what I've done wrong and other things, but do you remember when let's see, let's say I have a graph like this. What does that open circle represent? A hole. Okay. Hey, Lenny. See, brother. See, look at that. Three of a kind. Let's take this. Good to see you guys. We're just on the work page from yesterday. It was about the limits. All right. All right. So this part right here, this is a hole. Okay. Now, what I think I told you guys wrong yesterday, at least I think I told you this wrong, or maybe I'm just remembering from the past. Okay. So if we have a limit that is approaching this hole, or if I had a limit approaching the hole from this way, and so what they might say on this is this might be coming from the negative, this might be the positive. If the limit is coming to that hole, this y value is the limit. Okay? The only time this dot becomes it is let's say we have an xy axis, and let's say this is 4 and this is 2, and let's say this hole up here is at 5. So the limits for all of these would just be 5. This is all the limits, whether it's like this or like this or like this, and this is the same from the positive or to the negative. The only time this hole or this dot here is going to be the answer is if they say, what is the function at 4? So it's not even a limit. It just says, hey, the function at that point, this has to be 2. Okay, I think I messed that up yesterday. I'm so sorry. I hope it didn't goof things up. But with that known, hopefully with that correction, hopefully we corrected it quick enough that it doesn't embed in your heads that it has to be a certain way or the other. All right. So we're taking a look at this. This was the backside of it. This is one I asked you to try. Okay. So again, we're going to utilize Desmos when we're working on all of these. I'm sorry, I got to keep my computer plugged in because my battery got a little bit low. All right. So let's take a look at this very first problem. And they want us to find the limit as x approaches 1. Only one of these two equations is going to work. Okay? So we're going to use this one because we are including 1. So that's the only one we would graph. So if we went to, excuse me, my hiccups. If we went ahead and graph this, Desmos. Okay. We're just going to graph that very top one. So we have y equals x squared plus 1. And they say they want the limit as x approaches 1. Okay, so if you just kind of spread this out a little bit, make it a little darker. So right here at 1, oh, come on. So exactly at 1, the limit is 2. Okay, so the y value is the limit. So whether I come from the left side of the graph or the right side of the graph or both sides of the graph, I'll come to the same point. The limit in this case just exists as that. And then the next problem, we'll have to explain what I made an error on yesterday. I know because you came to me and said there was an error. All right. The next one says, hey, we want to evaluate, so we're going to have 1 divided by x. This is our next question. So down below here, this one right here. If I plug 0 into the denominator, I get 1 divided by 0. 1 divided by 0 is undefined. So we can't have that. Make sure phones are used at a minimum, unless you're on Desmos, please. And make sure your books are out. So if I go look at this, first thing I want to take a look at on this problem, there is not a plus or a minus. So this means it's coming from both sides. Okay? So if I take a look at the graph and we're looking at 0, so follow me in this adventure. As I come from the negative direction, the negative numbers, I'm going this way. And my graph is now going to go down. Where is this graph heading to? On my hand. It's going down to which infinity? Negative infinity. And if I come from this way, where is this graph heading to? Positive infinity. So depending upon the direction I come, I either go to negative infinity or I go to positive infinity. Does that make sense? And because our problem on here didn't say which direction to come from, you're coming from both sides. If it comes from both sides and you go to both to infinity or both to negative infinity, or you go to the same point, it exists. But this one, the limit does not exist. DNE does not exist. Okay? And the reason this one doesn't exist is because as I come from the left and as I come to the right, in the y direction, I'm either going to positive infinity or negative infinity. I'm going to two different locations depending upon the way I come. So this limit doesn't exist on this particular problem. Now, the grateful thing about Desmos is we're able to see it right away what it's doing. If you were doing it by hand, it's much more difficult to verify how this works, and it becomes one of those where you have to start plugging numbers in. It actually gets into something called derivatives, which we'll get to a little later. All right, friends, is that okay? Does that make sense? So the next problem on our page says we have the limit, and you have 2x over x minus 3. Again, this is both sides. I'm coming from both sides because it doesn't say the limit as it approaches 3 from the negative or the positive. It's just there. So it has to go to the same location. Hopefully they both go to positive infinity or negative infinity. But again, it's kind of hard to tell without using some other fundamental math. So I like, again, Desmos is my buddy. I should have invested in this company, but I didn't. So use it enough. All right. So if you take a look at this graph, as we come to 3, okay? So if we just do this, x equals 3. So we have that vertical line. Does this limit exist? No. As I come from the left, it goes straight down to negative infinity. As I come from the right, it goes straight up to positive infinity. This also is one that the limit does not exist, okay? It does not exist because they're going to two different infinities. And then you get to the last one and you're like, oh, well, following course, it can't exist. Well, I'd like to say it does not exist, but I don't know. Again, this has to come from both sides, the right and the left. So we're going to take a look at it on Desmos. And I don't know why I cleared that, but y equals that. So then I get 2x over x minus 3 quantity squared. All right. Friends, what can you tell me about? If I come from the left, it goes straight up. So it's going to where? Positive infinity. As I come from the right, it's going where? So does this limit exist? It does. What is the biggest limit it could be? And this particular problem, oops, wrong one. This particular problem, because both graphs went and did this, it's going up to infinity. So what is the limit as x approaches 3? It goes to infinity. It goes to positive infinity. Okay? So that's the first part of that exercise. Does that seem to make sense? So again, So again, if we go back to what we had talked about before with it, if you have a hole in the graph, is the limit comes from left and comes from right and it goes to the same location, that limit exists. The only time that if you have a hole in your problem, if the hole exists, if this hole exists and you have a solid dot below that hole, the only time that this dot becomes the answer is when you are using functional notation. So this means that I would be plugging 4 in to get a point, get a y value. Okay, so I think, again, that's I made that error yesterday, and I apologize for my error, but it's not going to be the only error I ever make. I'm going to make plenty of others. And we always laugh at stirrups errors. Well, hello. How you be? All right, so we are a little over halfway down the page, right? All right. So now we start talking about limits as they go to infinity. So now this infinity is in the x direction. So if it's positive infinity, it's going to the far right. If it's negative infinity, it's going to the far left. And if you go to the far right or the far left, where is the graph going? The graph could go, could converge down to an individual point. It can shoot straight up to infinity, straight down to negative infinity. We don't know. So we're going to take a look at this 2x squared minus 6x and graph it and kind of, see for ourselves what it might look like. So we do y equals 2x squared minus 6x. And that's it. Okay. Pretty simple. It's a parabola. Okay. So it says on the problem for the first one, hey, as I go to infinity in the x direction, so as I go right, my graph is continuing to go up. So going up forever is going to infinity. And then the other one, if I go to negative infinity, go to the left, negative infinity, I'm going this way, again, my graph is going to infinity. So both of those limits for the 2x squared minus 6x, they are both going to positive infinity or just infinity if you don't want to put the plus sign because you're trying to save lead or ink. Okay, so both of these are going to infinity in that case. So for both these, they're both going to positive infinity. And you can put the positive if you want, you don't have to. Then for the next one, it's a similar looking problem. It just goes from x squared to x to the third. And we have a negative out front. So if we go on to Desmos, it's negative 2x raised to the third plus 6x. All right. So if we take a look at our graph, as I go to the very, very far right, where is my graph going in the y direction? Down to negative infinity. And then as I go to the far left, where's my graph going? Up. So as I go to positive infinity, my graph goes to negative infinity. And then as I go to negative infinity, my graph goes to positive infinity. And the reason we're able to say that is if we were to look at our graph, it's basically doing this. And that's what my graph's doing. So as I go to the right in the infinite direction, it continues to negative infinity and vice versa. Excuse me. All right. And then the last ones, they want the limit as we go, bless you, to infinity, but it has the plus minus. So it says, as I go to the right and as I go to the left, are they converging to the same location in the y direction? Well, there's only one way to find out. Two over x plus 3 All right. So this is a nice one. As I go to the right and as I go to the left, what does it appear my graph is getting close to? As I go to the right, is it shooting straight up as I go to the right? So what I mean is this. On my graph, you're seeing all of the wiggles that will take place on this graph. So as I go to the right this way, as I go to this way, the graph isn't going to do any more jumps and leaps and bounds and curves. It's just getting closer and closer and closer to the x-axis. And as I go to the left, it's getting closer and closer and closer to the x-axis. Okay, one's coming from the bottom, one's coming from the top, but the limit on that particular one is whatever the x-axis is. The x-axis is in the y direction 0. Okay, so these guys, being that the graph did this, it's doing this, and this is the x-axis. This means that this limit, this answer here, it's going to 0. Okay, that's the y direction. This is the y direction. Okay, even though one's coming from the bottom, one's coming from the top, they're still going to the same. Okay, does that make sense? What did I do? All right, taking a look at the next one, we have 5x squared over x minus 1. Over x minus 1. Uh-oh. All right. Okay. So for this particular question, this is a really goofy looking graph, probably something that you've never seen before unless you were just arbitrarily plugging things in. So as I'm going this way, this graph is going up to infinity. As I go this way, this graph is going down to negative infinity. So does the limit exist on this problem? Thoughts? It doesn't. They go to two different locations. One goes to positive infinity, one goes to negative infinity. So this one doesn't work. This had something that it's called an end behavior. Okay, so this actually, if I do this right, let's see if I can do it. If I graph y equals 10x, yeah, that'll work. And then how am I going to do that? This is basically the end behavior it's going with. I'm off a little bit because I tried doing a derivative in my head and I'm off. So basically there is a diagonal line that this end behavior approaches. That is not the limit. It is just an asymptote. It's two different things. And then the last question on the page, we have 4x squared plus 2x minus 1. Oops. 2x right there. And then 2x squared. Shoot. Minus x. Did I do that? Prove that 2x squared x. Cool. Oh my goodness. That is one goofy looking graph. Yikes. But as I go to the far right, my direction on the graph, and as I go to the far left, what does it look like we are getting really close to? Is it 1 or is it 2? Look at my graph, how it's graphed. It's 2, right? So basically, this is going along with y equals 2. It's going along with that line right there. So our limit on this particular problem is 2. Oh, what did we say this one was? Does not exist, right? Okay, DNE. Cool. All right. So, are you ready for me for 10 problems? Okay. So I want you to work on this, but I want to do one of them. I'm going to do this one right here. Number 11, f at 6. So if I do f at 6, I'm going to look at this 6 right here, and I'm going to come up to wherever I have a dot, a solid dot, which is right here. So f at 6 is equal to 5. Okay, this is where f at 6 is at. Okay? But as the limit comes to, on that particular point, you can either get to, depending on which way you're coming, you either get to +2 or you can get to 5. It's one or the other. So will you take the opportunity to do these 12 problems and have out what I just went over? If you have it, I'll give you the points. If you don't, well, I know where our video is, but I'm going to stop recording here.